Hello and welcome to this video. I am Karnesh Johri and this video is about copy and move in C++. Objects of basic types like int, char, double are routinely copied. Even for concrete classes, if their objects comprise of data members which are of basic fundamental types, the copy semantics is member-wise copy. Each data member is copied from the source object to the destination object. But when we have a source object of slightly sophisticated type like vector, it is a little different. A vector has a pointer to an array of some type like double. So member-wise copy is not correct. We need to allocate memory for the elements and set the pointer to the start of the array in the vector object. When we design a class, we need to think how objects would be copied. And we need to add a copy constructor and copy assignment operator to the class. Then there are issues of runtime efficiency. What happens when we want to copy a large object, say a vector of 5000 doubles? There are processor and memory overheads. When we want a copy and we do not need the source object after the copy, we can simply move the data from the source to the destination. This leads to move constructor and move assignment operator in the class. Let's look at copy and move in a little detail. Consider a class vector which is vector of doubles. It has a constructor which creates a vector from an initializer list of doubles. It has a destructor and the subscript operator overload function for finding an element of vector given the index, and the size function which gives the size of the vector. So it is a very simple vector class, and we create a vector of 6 elements: 2.01, 4.99, 6.908, 9.007, 0.001 and 67.697. Next we say v2 equal to v1. We don't have any specialized code for copy constructor, so the default copy constructor is used, which is member-wise copy. So the element pointer in v2 is copied from v1 and both pointers point to the same array. Now we change v13 from 9.007 to 2.73 and we look at v23, which is also changed from 9.007 to 2.73. This is an error. The program ends and the destructor for v1 is called. It deletes the element array, and the destructor for v2 is called, which tries to delete element array, but there is no element array there to delete. So we get errors and the program aborts with a core dump. So the default member-wise copy leads to errors in this case, and we need to make changes. We need to add a copy constructor to the vector class so that a new object, which is copy of the past object reference, is correctly created. A reference to vector A is passed as parameter to the constructor. In the member initializer list, a new array of doubles of size a.sg is created. Also, sg is initialized with a.sg, and after that, the elements of vector A are copied into the elements of the object being created. Similarly, we have the copy assignment operator overload function. We create an array of doubles of size a.sg and copy the elements of vector A in it. We delete the old elements and make the pointer element point to the new array. We set sg to a.sg and we return a reference to the object. And now, getting back to the previous program, we have added the copy constructor and the copy assignment operator. And now when we say v2 equal to v1, the copy constructor is called, which creates vector v2, which is a copy of vector v1. Now v1 and v2 have separate copies of elements, So we can safely make v13 as 2.73 and v23 is not affected. It is still 9.007. And after this, vector v3 is created and we say v3 equal to v1. Here copy assignment operator function is called, which copies v1 into v3, and we can check the values of v3 by printing the elements. Copy constructor and copy assignment operators can be resource intensive. Copying takes time, but if the source is not required anymore after this operation, instead of copying, we can simply move the data from the source to the destination and save the time for copying. We have the move constructor and move assignment operator functions for our vector container class. Let us first look at the move constructor. The notation vector &&a means the reference to the R value of vector A. For any name, there is the L value and R value. The L value comes on the left side of assignment operator and the R value comes from the right side of assignment operator. So the name is the L value and the data associated with the name is the R value. Here we are interested in the data, and vector &&a gives a reference to the R value, and move constructor is quite simple. The most important part is the member initializer list, where the element pointer is copied from a.element and sg is copied from a.sg. So we get the data, or the data is moved. Now vector A doesn't have a valid data anymore, so a.element is made null pointer and a.sg is made 0, and our object is created, which is a copy of vector A. We have saved the time that would have been spent copying the element array. And then we have the move assignment operator overload function, so that move can be used in case of assignment operator. Here again, input parameters to the function is a reference to the R value of vector. We delete the old element array, and the important part highlighted is we take over the element array of vector A and copy the size a.sg to sg. As a part of housekeeping, we make a.element null pointer and a.sg as 0, so there is no data left in vector A and it cannot be used anymore. We return a reference to the object. How does the compiler decide which constructor or assignment operator is to be used? There are two distinct use cases. A constructor is used when we create an object from a class, and assignment operator is actually assignment overload operator function and is used when the assignment symbol is used in an expression. By default, the copy constructor and copy assignment operators are used. In case of copy, there is no loss of data and these are kind of safer. In case of move, data is moved from the source to the destination, resulting in loss of data at the source. So a compiler generally cannot decide whether a variable won't be required later on. But in one case, there is no ambiguity. Consider the example, which is plus operator overload function to add two vectors u and v. And the last statement, return w, returns the vector w by value. So here, vector w, which can be quite big, is to be copied to the scope of caller so that the caller can use the result of addition of vectors u and v. But after the return statement, w is no more required. So here vector w, instead of copy, can be moved. And if the move assignment operator is there in the class, the compiler uses it by default. The compiler generally cannot decide whether to use move or not. But we can specifically write st:\move L value, which converts L value into the reference to associated R value, and the concerned move constructor or move assignment operator is used. For example, we can say vector v3 braces std:\, move v0 and the move constructor is used. And in the case of vector v5 braces v4, copy constructor is used. Here we have the example program, class vector. It has two data members, double pointer element and size tsz, and the public member functions, the constructors, the default constructor. It creates a vector of size n with elements initialized to 0, then a constructor to create a vector using initializer list. Next, copy constructor and copy assignment operators. And then we have move constructor and move assignment operator. Next, the destructor, operator subscript overload function for getting the element at given index, and the size function which gives the size of the vector. The operator plus overload function adds two vectors u and v and gives the result as vector w, which is an example of move assignment. Since w is not required after the function, its value is moved to the calling function. And the main function, we create vector v0 for use later. And the vectors v1 and v2 both having 5000 double elements, and we give some random values to the elements of v1 and v2. Next, v0 equal to v1 plus v2. This is a user operator plus overload function and an example of move assignment. And then an example of move constructor, we say v3 braces std double colon move v0. So we get a reference to the r value of v0, which is used for initialization of v3. Since it is a move constructor, value of v0 is moved to v3. Next, we create v4 and the statement v4 equal to v1. This is an example of default copy assignment. And lastly, we have v5 braces v4, which is an example of copy constructor. v5 is created and v4 is copied into v5. We can compile and run this program. It works fine. It prints a lot of diagnostic messages which confirm what we have coded in the example program. We have seen the copy and move semantics for objects in C++. You can find all this information at SoftPrayog website. Here's a QR code and the link is there in the description. Please share this video and subscribe to SoftPrayog channel. Click on the bell icon and enable notifications. Thanks very much for watching. Take care and stay safe.